Welcome to this lesson where we're going to discuss one of the two question types you'll encounter on the quantitative section of the executive assessment, the data sufficiencies. So, the data sufficiencies are the proprietary, unique question type of the executive assessment and, by extension, the GMAT that the GMAC produces as a way of testing managerial competency through mathematic understanding. So, the logistics of the problem, they're basically 50% of the 14 quantitative questions that you'll encounter in an executive assessment quantitative section. You're going to have 5 constant options, though. The answer choices never change. They're going to correlate to which conditions are or is sufficient to provide a definitive answer to the question posed without you fully solving for it. So, the theory behind this is as a manager, you're going to want to be able to determine if a job could get done, but not necessarily perform the job yourself. So, that's kind of what's happening with the data sufficiency. You evaluate the information that's provided to determine if the answer can be reached, but you don't necessarily need to waste the time solving for it in its entirety. Now, there are two types of data sufficiencies that you'll encounter. Value, where you just have to determine is there one definitive value that is going to be the answer to the question, as well as yes or no, which just means that there's definitely a yes answer or a definitely no answer. And you have to remember that both definitively yes and definitively no are sufficient outcomes for these yes no data sufficiency types. So strategically, you have to memorize the constant choice definitions. You don't want to be reading the answer choices every data sufficiency problem. You'll be at a deficit compared to any other executive assessment test taker who is prepared and knows what those answer choices mean. And you'll probably be able to memorize them. If not after this lesson, very shortly thereafter when you do your practice. You're going to have the same average time per question for data sufficiencies as problem solving. There is no differentiation between the time you'll spend on an average data sufficiency versus an average problem solving, just under the 2-minute, 10-second average that you have for the quantitative section, because some data sufficiencies take longer, some problem solving questions take longer. It really just depends on the structure of the problem, as well as your proficiencies and what you're better at or worse at. You do have to have that hard cap of 3 minutes for any question, and you want to approach these problems very consistently to facilitate effective and efficient elimination. You're not going to want to jump around in your process and approach with the data sufficiencies. And you want to articulate all of the information that's provided as mathematically as possible to streamline your evaluation and be as efficient as possible. So let's take a look at a sample value data sufficiency. So we've just got a statement. If an integer is greater than 7, what is the value of x? So this is a value data sufficiency because we're being asked, is there one definitive outcome for the value of x? We are then provided with what are known as the conditions. So we've got condition 1, which is that x is less than 9, and this would be by itself sufficient because if x is known to be greater than 7, it can't be 7 or any value less than that. And we know it's an integer, so it can't be like 7.4. But if x is less than 9, well, it also can't be greater than or equal to any integer greater than 9. And there's only one integer that is between 7 and 9. That is a possible value for x. That, of course, would be 8. You don't need to figure out what the integer is, although for this example, you probably are going to do so as part of your evaluation. And we know that x is only possibly 8, so that means that condition 1 on its own is sufficient. Now, if we look at condition 2, we discover that x is greater than 10. Well, we already knew x was an integer greater than 7. This just tells us that x cannot be equal to 8, 9, or 10. But it could be any integer value greater than 10 and therefore is not sufficient on its own, this condition of statement 2. So this would be something that is not sufficient for the value data sufficiency. Now, a yes-no data sufficiency just kind of changes the question a little bit. So here we're being asked, if x is an integer greater than 7, is x greater than y? So we get the same root statement of x is an integer, it's greater than 7, but now we're being asked to compare x to some other value y definitively. So if y is less than 5, then yes, x is always greater than y because x is greater than 7, y is less than 5. So therefore, because y is less than 5, it's also less than 7. So x is greater than y and statement 1 is sufficient because the answer to the question, is X greater than Y, is always yes. But condition 2, if we're told that X is equal to 10, well, by itself, that's not going to be sufficient because we have no idea what the value of Y is. So that by itself isn't going to allow us to determine whether X is always greater than Y or not. So we would say that statement 2 here is not sufficient. So as far as the choices go, this is really important. You want to commit to memory a little mnemonic of 1 to 10 for the data sufficiency choices. We'll also have a process that'll make it so that you're always eliminating some variation of or some combination of the choices. But 1 to 10, if you ever get stuck, you can just remember this and you'll know what the answer choices mean. So this is going to correlate to the sufficiency of those statements 1 and 2. A means 1 alone is sufficient, but 2 alone is not. So hence the 1. 2 correlates with B. So B means that 2 alone is sufficient, but 1 alone is not sufficient. Now, the C correlates with the T in the 10, the word 10, not the number 10. And C means together the statements are sufficient, but neither alone is sufficient. And this is a very important distinction that we'll talk about in greater detail through this lesson. D is then going to correlate with the E in 10. So each statement alone is sufficient. So meaning 1 by itself is sufficient, 2 by itself is sufficient. Our answer choice is D. And then the E in the mnemonic correlates with the N in 10. And that means that neither alone nor together are the statements sufficient. So 1, 2, 10 is how you can memorize your data sufficiency choices. So our data sufficiency process. Step 1, carefully read and evaluate the given conditions as mathematically as possible by just asking yourself 3 questions. First, what do I know? We'll note that with a little K and a colon, and we'll say mathematically what the information is telling me. Like before, it said X is an integer greater than 7. I'd probably just write down a little X greater than 7 sign and no fractions allowed. Then we're going to ask ourselves, what are we looking for? And you're going to note the question, put the question in a box so that you never lose sight of what you're being asked for, and note if it's a yes/no format data sufficiency. So if it's a yes/no, you have to make sure to catch that because there are some slight variations, and obviously there's a little bit of a different process to answering the question. So if it's yes/no, note that. If it's value, you don't have to say value because value is pretty much just the default position that you'll have. Then you want to ask, what do I need to find what I'm looking for? And we're going to note that with a little N and a colon that stands for what we need mathematically to answer the question that's in the box. Then step 2 is going to be to carefully read and evaluate statement 1 as mathematically as possible alone. We have to make sure that we don't bring in the others. And if statement 1 alone is sufficient, then our answer choices are going to be either A or D. Either condition 1 by itself alone is sufficient, but not condition 2, or each condition alone is sufficient, and the answer is D. But if condition 1 alone is not sufficient, then our option choices are going to be B, C, or E. So after condition 1, you'll always know my answers possibilities are either A, D, or B, C, E. Then step 3, you want to carefully read and evaluate statement 2, again, alone as mathematically as possible. So if 1 and 2 are each sufficient, you're going to select D immediately. If 1 is sufficient, but 2 is not sufficient, you'll select A immediately. If 2 alone is sufficient, but not 1, then you'll select B immediately. If either choice is sufficient, you stop here. Do not continue evaluating the conditions together if either of them alone are sufficient. Because if you do that, you'll talk yourself into a trap seat. So you have to make sure you stop your evaluation at this point if either alone is sufficient, because you'll have selected D, A, or B at this point. But if neither 1 nor 2 alone is sufficient, then your options are going to be C or E, and we have to go to step 4, which is to read and evaluate the statements together as mathematically as possible. If together they're sufficient, then we're going to select C, and if together they're not sufficient, we're going to select choice E. So let's go on over to the whiteboard and take a look at a couple of example problems to see this process live and learn how to approach this unique question type that is only produced by the GMAC as part of the GMAT or this test, the executive assessment. On the whiteboard here, we have a sample data sufficiency problem. And unlike the problem solving approach, we're not going to skip to the end to figure out what we're being asked for. We need to take notes as mathematically as possible as we go to maximize efficiency. And we start by just writing out this little k, and that indicates what we know mathematically. So we see in the first sentence, Filbert is creating a bouquet of flowers for his mother consisting of only roses, carnations, and daisies. So we know that R can be equal to the number of roses. We know that C is going to be equal to the number of carnations. And we know that D is equal to the number of daisies. Now, on the exam, you probably can just write out R, C, and D as the variables, but here for illustrative purposes, we're writing it out very completely. Then we learn that Filbert uses at least one of each type of flower for the bouquet. So that means that R is greater than 0, C is greater than 0, and D is also greater than 0. How many carnations are in the bouquet? So now we're just going to box off what we're being asked for, which is what C equals. So then we've got to consider what we need in order to determine mathematically what the total number of carnations or the variable C is without exception. So we have 3 variables, all right? So we've got R, C, and D. And if I wanted to solve for just C individually, well, then I just need one equation for C. So if I get one equation for C, well, that's going to be enough. But I also know that just abstractly, if I get 3 different equations for 3 variables, I can theoretically solve, because that's the basic rule of algebra, linear algebra, right? Is if I've got one variable of x, I need one equation to solve for x. If I got 2 variables x and y, I need 2 equations to solve for x and y individually. So I need either one specific equation for C, or I need 3 equations with no new variables. Because if we get a new variable, then we need another equation. So condition 1 says Filbert uses a total of 24 flowers for the bouquet. So I don't want to write 24 equals flowers. I don't want to introduce a new variable. But I do know now that C plus R plus D is equal to 24. But by itself, I can find no way to determine what that value of C actually is. I just know that the 3 things together are going to add up to 24. So this by itself is not sufficient. And we know that from the 1, 2, 10 structure, that means that A, 1 alone, isn't a viable option, and the E, which correlates with choice D, is not available either, because each alone are not going to work if 1 alone doesn't work. So our options at this point, and we can just write them out, are just B, C, or E to help me with process of elimination. Now, condition 2, algebraically, says 3 of every 8 flowers in the bouquet are daisies. Okay, so that means that D out of the total, so that's my C plus R plus D, is equal to 3 over 8. So we've got an equation. And on the exam, you're generally going to be well served to get rid of fractions. So I'm just going to multiply across like this to get rid of the fraction. So I know that 8D is now equal to 3C plus 3R plus 3D. And if I combine like terms, I know that 5D is equal to 3C plus 3R. But by itself, I've got one more equation, but the same variables. It's not enough to work from. So I can't figure out exactly what C is. So that's out. So B is gone. Now, knowing that C plus R plus D equals 24 as a combination, we can solve for something, but is it the right something? So we know that D over C plus R plus D, which we now know from condition 1, is 24. is equal to 3 over 8. So that tells me that D is equal to 9. But we're not being asked for D, unfortunately. So I can figure out what my values are here, but I don't know exactly what my number of carnations is. Because now, if I plug into that equation that we had worked through from condition 2, I know that 45 is equal to 3 times C plus 3 times R. And if I divide that out, we discover that 15 is equal to C plus R, which makes sense because 9 plus 15 would add up to the 24 that we're seeking. But I don't know what C nor R is individually, so this remains not sufficient. We eliminate choice C and we select choice E by very mathematically evaluating the information using algebra and variables to do so. So let's take a look at one more example here. And this time we've got a yes-no data sufficiency. So similar to what we just did, we're going to start with what we know. And we know that X and Y are positive integers. It's real easy to overlook that statement and just speed past it. But I'm going to write this out technically. We know X is greater than 0. We know Y is greater than 0. And there are no fractions allowed. So then we're told that X plus 5 is equal to Y. And then we get our question, is Y a perfect square? And a perfect square is an integer that when you square root it, produces an integer. And of course, this is a yes-no data sufficiency, so we'll just indicate that with a little y/n and box off our question so we don't lose sight of what we're being asked to solve for. So to determine if y is a perfect square, what we need is to find out, is the square root of y known to be an integer? And if that's the case, then y is a perfect square. So condition 1 tells us that x plus 5, or sorry, that x is prime. So now we're going to have to take that information that x is prime and apply it to the x plus 5 equals y, and that figuring out if y is a perfect square. Well, if x were to equal, say, let's just go with, I don't know, 2, right? Because that's the first possible prime number. Well, then we know that y would be equal to 7. And the answer here, is y a perfect square? The answer is no. No, it's not. So we've got to think, though, what are the perfect squares that y could be? Well, y could be 4, but then it would have to be a negative because x plus 5 would be negative 3 plus, or sorry, negative 1 plus 5 would give us 4, so that's not going to work. If we go up to 9, it would be 4 plus 5, and x wouldn't be prime, so that's not going to work. But if y were to equal 16, then y is a perfect square. And 16 minus 5, to satisfy the circumstances, x would be 11. And now we've got a circumstance where the answer is yes, because 11 is still prime, but now the 11 plus 5, which is our value for y, becomes 16, which is a perfect square. So we have both a yes and a no outcome for this data sufficiency. So we eliminate choice, or condition 1 as being sufficient on its own, and we're down to our options of B, C, or E once again, because condition 1 alone doesn't work, nor will each alone work because 1 itself doesn't work. So now we go to condition 2, and that tells us that y is less than 20. Well, this is relatively obviously not going to be sufficient because y could be any number of things, and a prime is included in that. So we can eliminate choice B. Now, when we combine our two statements, reuse values, because we know that y could equal 7 still, and y is less than 20. Y could also be 16, and it's still where y is less than 20, and we get both a no and a yes outcome for y being less than 20, and we don't even have to do extra work. We already know that that's not sufficient because we got both a no and a yes outcome, and by being efficient in your evaluation of condition 1 and thorough to a degree, you make it so that you don't have to waste time on the subsequent conditions. So don't cut corners on your data sufficiencies. Write out everything that you know and recognize that the executive assessment will reward good preparation. Again, it's a test of management, and preparing is definitely an important part of being a good manager. So go ahead and practice some data sufficiency drills on your own to improve your performance on this unique aspect of the quantitative section of the executive assessment.